tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, Assalamualaikum dan hai semua para guru, ibu bapa dan anak-anak pelajar sekalian. Selamat datang ke Pusat Tuition Akademi YouTuber bersama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Okay, jadi sebelum kita mulakan kelas, marilah kita membaca umul kitab Al-Fatihah. Untuk yang bukan Islam, bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Okay, amin amin ya rabbal alamin. Okay, apa khabar adik-adik semua? Sebelum tu cikgu nak ucapkanlah selamat berpuasa untuk yang beragama Islam. Okay, cikgu harap semua berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita yang pertama untuk sesi 2022. Okay, cikgu percaya adik-adik semua dah tak sabar untuk meneruskan kelas kita pada kali ini. Okay, seperti biasa cikgu perkenalkan diri cikgu dahulu. Nama cikgu Nur Izian binti Saleh dari SMK Teluk Panlima Garang, Selangor. Boleh panggil Cikgu Izian selaku moderator pada petang ini. Okey, pada petang ini kita bersiaran secara langsung dari channel Mr. P atau nama sebenarnya adalah Mr. P Kok Hua dari Kolej Tingkatan 6 Tun Fatimah Melaka. Okey, jadi siapa yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Mr. P. Okey, hari ini kita akan mempelajari fizik tingkatan 5, tajuk 1.1 Daya Paduan ataupun Resultant Force. Okay, kelas ini akan berlangsung lebih kurang 1 jam. Okay, selain itu juga kita ada ketua panitia kita iaitu Cikgu Hasnita selaku control host. Okay, sebelum kita teruskan kelas kita pada hari ini, ingin cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen untuk menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Jadi cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar cemerlang dan mari kita tunjukkan disiplin yang terbaik. Okay, link e-sijil akan diberikan di hujung siaran nanti. Pastikan diisi dalam tempoh 30 minit selepas kelas tamat. Link e-sijil hanya dapat diisi dengan email e-didik, MOE, Jawi dan My Guru. Okey, selain itu cikgu akan berikan kod untuk tebus ganjaran semasa kelas dijalankan. Okey. Jadi cikgu berikan kod yang pertama Kod yang pertama adalah A2. A2. Okey. Jadi sila fokus pada isi pelajaran yang akan disampaikan oleh Mr. P. InsyaAllah moga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Okey, jadi tanpa membuang masa lagi, saya serahkan kelas kita pada Mr. P. Silakan Mr. P.
Hi, hello, selamat petang. So welcome back to Class Tuition Percuma Fizik SPM. So berikut adalah jadual untuk sesi terbaru ini. So untuk kelas tingkatan 4 dijalankan pada hari Jumaat 3:30 petang dan kelas untuk tingkatan 5 seperti hari ini akan dijalankan pada Ahad pukul 2. Okey, ini merupakan panitia fizik SPM Akademi YouTuber Malaysia. So hari ini bersama saya, Cikgu P di konti adalah Cikgu Izian dan juga Cikgu Hasita. So terima kasih kepada cikgu-cikgu bersama saya di konti petang ini. Okey, so saya Mr. P. So kini mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka. So tajuk hari ini merupakan tajuklah pertama untuk sesi tingkatan 5 yang terbaru ini. So chapter 1 Force and Motion and the subtitle for today's will be Resultant Force. Okay, so for today's subtitle 1.1, we have total about 4 learning standard 1. Okay, so let us see together. So the first standard learning. So the first will be describe resultant force. So that means you need to know, okay, so what is the meanings by the resultant force? So the resultant force is the single force that represents the vector sum of two or more forces acting on an object. So here we have the situation one. You can see that, okay. So there is two students, okay. So pull the string, okay, to FA represented the force at the left side, and the FB will be the force pulled by another students, okay, to the right side. Okay, so here you can see the resultant force showing 0. This is because the magnitude for FA and FB is the same, but they are acting in opposite direction. So that means that when two forces, okay, is acting in opposite direction with the same magnitude, so the resultant force, which is represented as the final net force, will be 0. So here we have another situation showing that the FB, so the magnitude B to the right side is greater than the force FA, which is acting at the left side. So the net force, which is showing by the resultant force, is at the right side, okay, which is the direction for the force showing the greater value of force. So for situation 3, you can see that, okay, so the FA showing the greater value, okay, so that the net force or the resultant force will be to the left side, which is the greater magnitude of the force. So we can conclude that the resultant force or the final net force will be same direction as the force with the larger amplitude, magnitude, okay? Okay, so for the learning standard 2, you have to know how to determine the resultant force. Okay, so resultant force that act on an object in a plane. So we have total actually 4 situations, okay, which we can separate to 2 parallel forces acting on an object in a plane. Okay, so at another will be the 2 non-parallel forces acting on an object in a plane. Okay, so for the situation 1, under the 2 parallel forces, okay, so 2 forces acting in the same direction. So you can see in the figure here, the F1 and the F2, both forces acting at the right side, okay? And the situation 2, where the 2 forces F1 and F2 acting in the opposite direction. In the situation 3, which is under 2 non-parallel forces acting on an object in the plane, the first one will be 2 forces acting on an object perpendicularly to each other. So you can look at the figure, the F1 and F2, both forces acting perpendicularly. So that means it's right angle here. So for the fourth situation, 2 forces acting on an object, they are not in perpendicular to each other. So you can see F1 and F2, they are acting at the certain angle, which is not 90 degree. So that means maybe they will be 60, they will be 30, 100 or others. Okay, so now let us discuss one by one with you for the each situation. So for the first situation, 2 forces acting at the same direction, so will be quite easy. Okay, so what we actually need to find out for the resultant force, first we need to get the magnitude, okay, magnitude of the resultant force. So at here, when the two forces acting in the same direction, we will using vector additional. So that means we add the value for both forces which acting in the same direction. Okay. And another one, we need to find out the direction of the resultant force. Okay. So for case which the two forces acting at the same direction, the direction will be same direction with the forces. Okay. So if let's say you still not understand what I'm talking about, so I can give you one simple example. Okay. So I take from the textbook. Okay. What is the resultant force for these two forces acting in the point? Okay. In this point. So for the first force will be 6 Newton and the second force will be 8 Newton. Okay, so as mentioned, the magnitude will be addition for both forces, which is 6 and 8. So the magnitude will be 14 Newton. And the direction, you can look at the figure. So both of the forces is showing that the direction to the right. Okay, so the answer for the resultant force will be, you can see, which is showing as a single final net force, okay, in yellow color arrow, which the value of the magnitude will be 14 Newton and the direction is 14 is to the right. So the answer, you need to showing the magnitude, which is 14 Newton, and the direction will be right. Okay, so now we go to the situation 2. Two forces adding in the opposite direction. So you can look at the figure. So the F1 is showing the force at the right side, and the F2 is at the left side. Okay, so for the forces that acting in opposite direction, we need to subtraction the vector. So here we need to use the greater value, okay, minus the smaller value of the force. And the direction will be follow the force which have the bigger value of the forces. Okay, so here I also give you one example. So there are two forces adding at the point, okay, with the opposite direction. Okay, so the right side will be 6 and the left side will be 8. So here the greater value will be 8. So as mentioned just now, we are using greater value of the force, which is 8 minus a smaller value. Here is 6. So the magnitude will be 2 Newton. And the direction, we will follow the direction where the force showing the greater value. So here will be 8 Newton, which is at the left. Okay, so the answer here will be 2 Newton to left. So if let's say you want to show the diagram, you can look at the arrow of yellow, okay, which is showing the 2 Newton to the left side. Okay, so for the third situation, there will be two forces acting on an object perpendicularly to each other. Okay. Okay, so for forces which are perpendicular to each other, the resultant force can be determined by using the Pythagoras theorem. Okay. Okay, so here I give an example. Okay, so two forces acting on a box. Okay, where the first is showing 30 Newton and the second is 40 Newton, which both is acting perpendicular to each other. Okay, so step 1, okay, so you have to draw and combine the line of forces as in one direction. So you can see the 40 Newton force, which is to the right, and then the 30 Newton force at here show to the north. Okay, so the both direction of the force must be in the same direction. Okay, so the second, connect the two lines to find the magnitude and the direction of the resultant force. As mentioned, we need to get magnitude of the resultant force, and we need to get the direction of the resultant force. So that means that the F here showing that this line with double arrow here, okay, is showing the resultant force. Okay, so from here, we can using the Pythagoras theorem, okay? We square root 40 and square root 30, and we get the magnitude will become 50 Newton. Okay, so I think this is also quite simple for you all because you have already learned the method how to apply Pythagoras theorem, okay, to find out the hypotenuse of the triangle. Okay, so the F is the hypotenuse of the triangle. So we get the magnitude is 50. And the next step, we need to find out the direction, which is showing the theta here. Okay, so here we're using tangent because the opposite is 30 and the adjacent will be 40. So 30 over 40, we get 0.75. Arctangent of 0.75, we get 36.9. Okay, so and the 36.9 is actually from where? It's from the horizontal force of 40. Okay, so you can see the angle is started from the line of 40. Okay, so the 40 is the horizontal force. So you need to mention the angle is from the horizontal force, which is 40 Newton. Okay, so I think the situation 1 to 3 will be quite easy. Okay, so now let us practice together. Okay, so what we have already learned in these two different situations. Okay, so you can show your answer at the chat room. Okay, so for the first, calculate the resultant force that pulling the box in each of the following situation. Okay, so for the first one, you can see both of the forces, 7 Newton and 3 Newton, is actually acting, okay, in the same direction. Okay, so we assume that the right direction forces will be the positive. Okay, so 7 plus 3. Okay, so what is the value you can get? Okay, so you will get 10 Newton. Okay, and the position, the direction will be at the right. Okay, you need to show the magnitude and also the direction. Okay, so let us try for the second question. Okay, so you can also give the positive value for the right side and the left side showing the negative value. Okay, so here we will be 1 plus 2 and minus 5. Okay, so finally we get our final reading is negative 2 Newton. Okay, so the negative 2 Newton, that means that the negative showing that the direction of the resultant force will be at the left side. Okay, so here will be 2 Newton to left. Okay, so we come to our third situation. Okay, so where the 6 Newton and the 8 Newton forces both will be perpendicular to each other. Okay, so firstly, you can try to draw, okay, so the triangle, okay, so where the 8 Newton showing to the right and the 6 Newton force, okay, will be shown to the downward. Okay, and then you join the line, okay, where is the hypotenuse of the triangle, okay, which is that as the F as the resultant force. Okay, so that means that here the F will be the using the Pythagoras theorem. Okay, so as mentioned just now, so always making the direction of the line in the same direction. So you can see the case for the first one, A to O and O to B is same direction, and the second figure showing that the A to O and the O to B is also in one same direction. However, for the figure number 3, you can see the O go to A and O go to B, both is in different direction, okay? Okay, so they will be wrong. So in our case here, you can see the 8 Newton force to the right, and then the direction will go to the bottom. So showing that both of the forces is in the same direction. Okay, so let us see the answer here. Okay, for the hypotenuse, 8 squared plus 6 squared squared will get 10 Newton. And the direction will get the value of theta here. So again, we're using opposite, which
Mr. P okey ke tu?
Ya.
Nampaknya agak tersekat sikit ya. Okey, Mr. P dah ada tu.
boleh.
Okey.
Sorry ya,
Boleh,
tersekat
boleh.
Okay,
dah
so
okey.
that means okay, thank you bagi saya tahu. Okay, so di sini kamu boleh tahu the angle is 36.9 from the force of 8 Newton. Okay, so you just write the answer here. Magnitude will be 10 Newton and the direction will be 36.9 with horizontal force 8 Newton. Okay, so now let us go to the fourth situation to determine the resultant force where the forces acting on an object is not perpendicular. Okay, so this will be more difficult compared to the first three situations. Okay, so here we have actually two methods to get the resultant force, okay, which is acting not perpendicular. Okay, so the first method here, we're using the triangle of force method. Okay, so the question here, you can see there is two small boat pulling a large boat here, okay, with the force of F1 and F2 with the angle of 50 degree. Okay, so the F1 is 50 Newton and the F2 will be 70. Okay, so the first we have to choose the suitable skill to draw line that represent the magnitude of the forces. Okay, so here we can using 1 cm. Okay, 1 cm represent as the 10 Newton. So the 1 cm here, that means we need to draw a line. Okay, so here the F1 is equal to 50 Newton. So we will draw a triangle. Okay, so we need to have a three line. So the first line will be represent as the 15 Newton, which will be in 5 cm. Okay, because here in this case now, okay, so here you already mentioned that we're using 1 cm as represented 10 Newton. Okay, so the F2, which is 70 Newton, will be represented as 7 cm. Okay, so here you can see by using ruler and protractor, draw the force F1, okay, where is showing as OA, okay, OA. So 5 cm, you measure exactly 5 cm, and then using protractor, okay, place your protractor. You can extend this line and place the protractor to measure the angle. Here is equal to 50 degree. Okay, and then you have to draw line OB, okay, and measure as 7 cm. Okay, and then you have to join, okay, you have to join the line O to B. Okay, so the OA will be represent F1 and AB represent F2. So final OB represent as the resultant force. Okay, so you have to using ruler. Okay, using ruler and measure the line OA. Okay, so to get the magnitude. So we get the length of the OB will be about is about the 11 cm. Okay, so the 11 cm means that that is 110 Newton. Okay, so hi, finally got somebody respond me at chat room. Okay, so Jing Jingget, okay? So I hope that you can join my discussion together, okay? Okay, so as mentioned that for the resultant force, we need to get the value, okay? And then we need to get the direction. So here, the direction you have to measure by using protractor, okay? Protractor, okay, you get the value is about 27.5 degree. Okay, so that means that the answer here, the resultant force will be equal to 110 Newton, 27.5 degree with horizontal force OA, or you can mention as 50 Newton. Okay, so this is the method one where you can get your resultant force, okay, where the two forces acting on an object which is not in perpendicular. Okay, so the same situation, okay, but we're using second method, parallelogram of force method. Okay, so the how you draw the parallelogram, actually you have already learned at the PT3 mathematics, okay? Okay, so we're using the same question, okay? So how we use the second method to get the same result? Okay, so the first, you also need to choose the suitable. Okay, you need to choose a suitable scale. So as mentioned, 1 cm will be representing as the 10 Newton. Okay, so that means that the first line will be 5 cm, and the second line will be 7 cm, which is same as the previous situation. Okay. Okay, so here by using ruler and protractor, draw the F1, which is showing as the OA. So you have to measure 5 cm, and OB, you have to measure 7 cm. Okay, and the angle 50 cm, you're using the protractor to measure. Okay, and then the next step, okay, you have to complete the parallelogram here. Okay, you can using the compass, okay, to draw. You measure your OA, 5 cm, and from here you have to measure 5 cm here. And you measure your OB, which is 7 cm, and from this point, you get your 7 cm here by using compass lah. And then you have to complete your triangle, your parallelogram. And the next step, you have to extend your line. Okay, from O to C, okay, which is showing at this figure. Okay, so again, you measure the length of OC. Okay, so you will get the OC, the length will be 11 cm, which is equal to 110 Newton. Okay, so and you have to using protractor and measure the angle alpha here. So you will get the same answer, which is also 27.5 degree. Okay, so end up, you have to mention that your resultant force, okay, will be 110 Newton, 27.5 degree with horizontal force of OA, or you can mention 50 Newton. Okay, so this is the example for the second method. Okay, parallelogram of force. Okay, so now we go to our third learning standard. Okay, so in this learning standard, okay, so you have to communicate about resultant force when an object is in stationary, moving with constant velocity, moving with constant acceleration. Okay, so that means just now we have already know how to get our resultant force, okay, by using different method. For example, just now we have the additional method for two forces acting in the same direction, and we using the subtraction method where the two forces acting in the opposite direction, okay, and we using theorem Pythagoras for the forces acting in perpendicular, and we're using triangle and we're using parallelogram method for the forces that acting which is not in perpendicular. Okay, so when we already get our resultant force, but they will be in different situation. Okay, so here we discuss 3 situations will be affected the resultant force. Okay. Okay, so resultant force on an object in various state of motion. So for just now, I already mentioned we have about 3 different state. Okay, so before we go to our further discussion, okay, so you have to understand. So what is the free body diagram? Okay, so free body diagram will be a diagram that shows all the forces acting on the object only. Okay, so actually it's quite similar to the figure just now, where the two or more forces, okay, or acting on the point. Okay, so here we have to discuss situation object, and the second will be moving object. Okay, so the page for this page will be we discuss about the stationary object. Okay, so the first free body diagram of a book on a table. So the book is stationary and stand on the table. So there is actually 2 forces acting on the book. So the first will be the weight of the book, and the second will be normal reaction from the book. Okay, so what is the normal reaction? So this actually is related to the syllabus Form 2 Science, okay, Chapter 8. Okay, so in that chapter, you have already learned what is the Newton third law. So Newton third law states that every action force, there is a reaction force of the same magnitude but opposite direction. So that means that W, weight of the book, is represented as the action or force, and there will be another force, we call that as the reaction force. They will be have the same magnitude but opposite direction. Okay. Okay, so second, we have another example here is a free body diagram of a bag on a inclined plane. Okay, so here you have to identify all the forces acting on the bag. So here we have the W, where is the weight of the bag, and the R will be the normal reaction from the inclined plane. Okay, and the N here will be normal reaction from the wedge. Okay, so as mentioned, so the normal reaction here is actually come from the action force, where come from the W. Okay, okay, so let us continue the for free body diagram with the object, moving object. Okay, again, we will be applying the third Newton law in the example here. So the first free body diagram of a moving trailer. Okay, so here you can see the trailer is moving at the right side. Okay, so when the trailer moving at the right side, there will be the frictional force where the tire and the ground is touching together, right? Okay, so will be resulting a frictional force. Okay, so you can look at here, we have 4 different forces. So the pulling force is actually produced by the engine. Okay, so is here is considered as the horizontal force. Okay, where this is actually the action force and produce the reaction force, where showing by the frictional force. So another one will be the weight and the normal reaction. Okay, so these 2 forces is acting vertically. Okay, so the weight is at the downward, which is the action force, and resultants the uh, reaction force, which is the normal reaction. Okay, so here we have another example, free body of the moving rocket. Okay, so here the rocket move upward. Okay, so showing by the engine thrust of rocket, and there is another 2 forces acting downward. Okay, where there is the weight of the rocket, air resistance. Okay, so here we discuss about how you can draw and identify all the forces acting on the object and show by free body diagram. Okay, so here we have the checkpoint where is the practice regarding the free body diagram. Okay, so label the forces acting on the object in the following diagram. Okay, so here apple hanging in the air. So the first we have our action force. Okay, so again we using the Newton law. Okay, we need to know our action force and the reaction force. So the action force here will be weight, and the reaction force here you can see this is a string. Okay, hanging here. Okay, so the force here will be called tension. Okay, so force applied on the string we call tension. So at the example 2, we have the 3-4 feather. Okay, so again, the feather have its own weight acting downward, and the reaction force will be the air resistance here. Okay, so come to our third uh, example C here. So bird flying in the air. So the bird have its own weight, which is at downward, and the reaction force here is the lift force, which is at the upward. Okay, and the bird fly in front. Okay, so showing there is the thrust, and the reaction force here will be a drag, or we can know as also air resistance. Okay, so from here you can actually know how important to get all the forces which is showing in the free body diagram. Okay, so the magnitude of the resultant force on an object in different state of motion. Okay, so here we discuss 3 different states, okay, as mentioned. So the first will be stationary state. Okay, in this we will apply Newton's second law where F equal to ma. Okay, so this is a car which in the stationary state. Okay, there are 2 forces acting on the car, where the W is the weight of the car and the R will be the reaction force and known as normal reaction. Okay, so there is 3 relation will be 0. Okay, so the resultant force here we only have the vertical component only. Okay, so where the W is equal to R. So the resultant force will be W minus R equal 0. Okay, so the resultant force here is 0. The second is uniform velocity. So the velocity has its own value, okay, which is constant. So with the constant velocity, that means that there will be zero acceleration. So this already learned at your last year Form 4 syllabus, Force and Motion 1. Okay, so here we have our vertical component, okay, which is showing by R and W. Okay, and here the resultant force will be 0. Okay, and then for the horizontal, okay, which is showing by the FR, okay, which is the friction, and the T will be thrust. Okay, so because of the velocity is constant, so that means the resultant force will be also 0 lah. Okay, so at our next condition where the car moving with a uniform acceleration, okay, so the figure, the free diagram, body free diagram will be almost same as the uniform velocity, okay, but there is some difference here. So here the velocity is increasing, so that means the value here maybe it started from 80 and then next come to 100 or 110. Okay, so we're showing the increasing velocity. that means that the acceleration is no more 0. Okay, so there will be the resultant force for the vertical part is still showing 0, okay, because the car is moving at the right side. Okay, for the upward and downward side, okay, so actually it's maintained constant. So that means there will be still 0 for the resultant force for the vertical component. Okay, for the horizontal, T will be greater than frictional force. Okay, so that means the resultant force will be no more 0 lah. Okay, so the knowledge at 1.13 you have to apply, okay, at our last learning standard here. Okay, so solving problem involving resultant force, mass and acceleration. So that means this is actually second Newton law, okay, F equal to ma. Okay, so for the problem solving here, we have actually 4 models here. So the first model is the resultant force acting on the object, okay, moving horizontally. So the second model will be resultant force acting on an object moving vertically. And the model 3 will be resultant force acting on an object in elevator. And the last will be resultant force acting on a object pulled by using pulley. Okay, so we discussed our first model. So resultant force acting on an object moving horizontally. So model 1 and model 2 will be quite easy lah. Okay, so here we have the case. Okay, Ali pushing trolley of mass 15 kg with the force of 5 Newton. Okay, we put as T lah here. Okay, symbol T. So what is the acceleration of the trolley? So the question asks us to find out what is the value of A. Okay, so given that the frictional force, which is the Fr equal to 2 Newton and showing in the opposite direction with the pulling force. Okay, so step 1, you can draw your free body diagram. Okay, will be almost like this. Okay, so the 5 Newton is the pulling force showing by T, and then the 2 Newton will be the frictional force where adding at the opposite direction. The step 2 will be the resultant force. Okay, as mentioned earlier, okay, so this is the subtraction vector because both of the forces is acting at the opposite direction. Okay, so 5 minus 2, we get 3 Newton. Okay, and then we have to apply our Newton's second law, F equal to ma, to get our A. Okay, so from here, we have already get our resultant force as 3 Newton, and the question given us the mass of the trolley will be 15 kg. So we just substitute to the equation, and we get our A equal to 0.2 meter per second. Oh, sorry, here it will be meter per second square. Okay, so the hot tips here, you have to give your answer in 2 decimal place, but here we can show 1 decimal place because this is the exactly answer from the calculator, and you must showing your correct unit, okay, at your answer. So for the second model,
Mr. P,
yeah,
boleh saya bagi kod yang kedua sebelum kita rehat?
boleh?
Okay. So adik-adik, kod yang kedua adalah 31. 31. Okay, kita rehat dulu boleh?
Boleh?
Okay.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Okey, kembali bersama di Pusat Tuition Online Percuma Akademi YouTuber. Okey, cikgu nak ingatkan adik-adik kalau nak ada soalan boleh terus tanya di ruangan chat. Nanti cikgu Mr. P boleh jawab ataupun cikgu sendiri ataupun cikgu Asnita. Okey, silakan Mr. P.
Okay, so thank you, Cikgu Izian. Okay, so we go to our second model, okay, where the resultant force acting on an object moving vertically. Okay, so this is the question here. Okay, so a coconut with the mass of 2 kg falling with the acceleration 9 meter per second square. Calculate the resultant force acting on the coconut. So what is the magnitude of the air resistance acting on the coconut? So here, firstly, we need to draw the free body diagram. Okay, so we have the R represented as air resistance, which is showing outward, and the mass of the coconut given as 2, and we have the weight of the coconut, okay, equal to mg. Okay, so this already learned at your force and motion 1, okay, at section 2.8 also. So 2 is given by question where is 2.0, and the the G will be 9.81, okay, given by the question also. So we get the weight of the coconut will be 19.62. So second step, we apply our formula F equal to ma, okay, because the question asks to find out the R. Okay, so using formula, if we compare for the just now, we just using the vector subtraction here. But here, because of the R is not given, where we need to find the answer, we can just reverse the method. Okay, we're using the formula F equal to ma. Okay, we get our resultant force is equal to 18. Okay, and then we only use the vector subtraction here because the two forces acting here is in opposite direction. Okay, so the weight is greater than R because the coconut, okay, moving downward. Okay, so that means the weight will be greater than air resistance. So we substitute 18 where we already find out just now, and we also get our weight at our first step. We substitute all the value and we arrange, we get our R is equal to 1.62 Newton. So again, I advise answer in 2 decimal place and with the correct unit. Okay, so now we go to our discussion, okay, in the question 3. Okay, so a force of 8 Newton here, okay, pulled by a trolley with a mass of 2 kg along a straight line. So the trolley has the acceleration of 2. Okay, so all the parameter already given in the question. So the question asks us to find out the frictional force against the motion of the trolley. So where is the frictional force? Will be acting at the opposite direction with the pulling force. Okay, so again, we can draw, okay, the free body diagram, okay, so almost like this, and we need to find out what is the frictional force. Okay, so question given us the value here, A equal to 2, M equal to 2, and pulling force is 8. Okay, so we just substitute the value given into the formula F equal to ma. Okay, we get almost like this, okay. Then we get our frictional force will be equal to 4 Newton. Okay, so we have already break, okay, so we just continue our third model, okay, where the resultant force acting on an object in an elevator. Okay, so model 3 and model 4 will be a bit difficult compared to model 1 and 2. Okay, so at this model 3, there is an important terms you need to understand here. Okay, so the reading on a weighting scale, weight is also known as the apparent weight. When a person weighs himself, is actually the reaction force that act on him. Okay, so here we'll discuss three different cases. The first will be the stationary or constant velocity. Okay, so as mentioned just now, by applying the Newton's third law, so the weight acting downward, there will be another reaction force will be applied with the opposite direction. So here will be the R. Okay, so we know as the apparent weight, and the weight will be appear the value at the weighting scale. Okay, so for the stationary, okay, for the stationary and the constant velocity, so the A will be the same. So the A will be 0. Okay, so the first we get our resultant force equal to 0, and from here we know that the R will be get equal to mg. So that means at the stationary condition, when you weight your weight, they will be same as the weight where you weighing at the scale lah. Okay, so this is the first. So for the accelerate upward, so that means the R will be greater than mg because the direction is upward. Okay, so at this situation, because the A is already no more 0, so there will be the value for resultant force. Okay, so with the formula F equal to ma, so the resultant force here will be R minus W, okay, because the direction is acting upward. Okay, so we will arrange the formula where W equal to mg, and we move negative mg to another side, we get R will be mg plus ma. So that means with the accelerate upward condition, you will see that the weighting scale given the value is greater than your body weight. Okay, and at the case number 3 will be accelerate downward. So when accelerate downward, that means that the W will be greater than R already. Okay, so this is the acceleration motion. That means there is not 0 for the resultant force. And by applying the same formula, F equal to ma, so here W will be greater than R. So W minus R equal to ma. Okay, so mg will be the value for W lah. So we arrange again, we get our R will be mg minus ma. So that means you will see the weighting scale will be showing lower value. Okay, lower value than your body weight if the elevator is accelerate downward lah. Okay. Okay, so here we have example here. So a 60 kg student is standing on a weighting scale in an elevator. So showing at the figure here, and the G will be using 10. Okay, so let's see what the question asks about. So what is the reading of the weighing machine when the lift is moving upward with the constant velocity? Okay, so with the constant velocity, so that means that this is the case 1. Okay, so the weighting scale, that means the question asks us to find the value of the R. Okay, so this is a case 1 where the A will be 0 and the resultant force will be 0 lah. Okay, and the question given us the M is equal to 60 kg and G is equal to 10 here. Okay, so by applying the formula of second Newton law, okay, F equal to ma, and the MA will be 0 because the A is 0. Okay, so from here, W minus R. You want to put W minus R or R minus W, you will get the same result. Okay, where W will be equal to R. Okay, so R will be equal to mg. So the M will be 60, G will be 10. So the answer here, the weighting scale will be showing exactly the weight of the person lah. Okay. Okay, so for the question number 2, okay, the question asks you also, okay, what's the reading of the weighting scale? Okay, where the situation now is changing. Okay, so the lift is moving upward with the deceleration. Okay, however, we consider moving upward, there will be case 2 lah. Okay, okay, so the most important here is the value of A you must showing negative because of the deceleration. Okay, so from here we apply also the second Newton law, okay, where there is the F equal to ma. So as we mentioned just now, as the lift moving upward, so that means the R will be greater than W. Okay, so we arrange the formula again, we get mg plus ma. So we substitute all the value given in the question. M equal to 60, G equal to 10, and the A will be -1. So must be very careful for this value here, -1. So here will be 540 Newton, which is less than the weight of the students. Okay, if let's say we discussed about the example just now, when the lift moving outward, the result will be showing better than the person. But here, because of the deceleration, the weighting scale showing the lower value. Okay, so here we can conclude that with the moving upward acceleration condition, the R will be more. That means the reading of the scale will be more. Okay, but if the moving upward condition with together with deceleration, the value of R will be reduced. Okay, so there is another question here. Okay, also about the lift, but now the condition is changed already. So moving downward with the acceleration of 2. Okay, again ask you the reading of the weighting machine. So this is the value for R. Okay, but here is the case number 3 where it's moving downward. So the question given M equal to 60, G equal to 10. Okay, so here here we have the mistake here. So A equal to 2. Equal to 2. Okay, so we're using the same formula. Okay, we get our value here is less than the weight of students. Okay, so again, we can make a conclusion here with the moving downward together with acceleration, we will get reading of the R less than the body weight of person. But let's say the moving downward condition together with deceleration, you will be see that the reading R, okay, or the weighting scale reading will be more than the weight of the person. Okay. Okay, so we go to the model 4. Okay, model 4 is regarding the resultant force acting on an object pulled by using pulley. Okay, so actually for model 4, we have many cases now, okay, but here I just discuss 2 cases, okay. So 2 blocks are connected through a smooth pulley. There is a frictional force between the block and the table, so it's here. So the case 1 will be almost like this lah. There is 2 blocks. Okay, one of the block is touching, okay, the table surface. So when 2 surface contact to each other, so the frictional force will be produced lah. Okay. Okay, so first again we need to draw free body diagram. So how we read the system here? Okay, so for the pulley system, actually you can get about 3 equation. Okay, 3 equation with the different observation in the system. Okay, so the first, if let's say we look at the whole system, so that means exactly the whole diagram here. Okay, so you have to only see the end-to-end forces applied on the system. We don't need to see the forces at the middle part, which is showing as the tension of the string here. Okay, so we just see frictional force and the weight of the block with small letter m. Okay, so from here, first step, we identify the resultant force. Here, we very sure that the mg here will be greater than frictional force because the motion is to the downward. So that means the mg is greater than the g. So the resultant force for whole system will be mg minus frictional force. So step 2, apply the formula for the second Newton law, F equal to ma. So the F will be equal to the resultant force, where mg minus capital G. And the m here will be the total mass of the system here. So we have the capital M block and the small letter m block. So we have to addition both of the masses with A. Okay, and then you have to solve your equation. Okay, so the second equation you can get from the partial system here. Okay, so what is by partial system? So here actually we have two systems. One system is system of block small letter m. So I'll discuss the what equation you can get from here first. Okay, so again, you can draw the free body diagram for the partial part of the block small letter m. Okay, will be almost like this. So you can see the A value acceleration is downward. So that means the W will be greater than T. Okay, again, we get the resultant force will be mg minus T. And then second, we're using our formula F equal to ma. So our resultant force will be mg minus T equal to ma. So we have to solve the equation. Okay, so and third equation we can get at another partial system here, which is showing by the system block capital M here. So again, you can draw the free body diagram like this. So the air showing to the right direction. So that means that T will be greater than G. So the resultant force will be T minus G. So we substitute to F equal to ma, we get this third equation. Okay, so why we want to get so many equations? Because we want to get the unknown value in the system. Okay, so here we have two important actually top tips here you want to remember. First, you can get 3 different equations. At least you can get 3 equations from 2 different systems, which is a whole system and partial system here. And after that, you get your 3 equations, you must solve the equation. Okay, sometimes you need to apply substitution or elimination calculation where you have actually learned at your PT3 mathematics already. Okay, so here I give one example here. You will be more clear what I actually want to bring the information to you. Okay, so here in the following, there is the 2 pulley system. So 10 kg block and 5 kg block here. So what is the resultant force adding on the system? So that means the question asking us the whole system of the resultant force, not the partial system. So you have to look at the whole system. So when we look at the whole system, we just need to look at the end-to-end forces acting on the object, on the system. So will be G, which is the frictional force, and the W will be weight of the 5 kg block. Okay, we not need to use any weight of the 10 kg block or tension here. We just need to apply end-to-end forces acting on the system. So here the air is moving downward, so that means W will be greater than G lah. Okay, so we get the resultant force will be W minus G. W will be mg. M equal to 5 and G will be 10. Okay, given by the question. and we minus our frictional force, then we get our value will be 40 Newton. Okay, so B question asks us about the acceleration. Okay, so we can using our second formula here. The first will be calculate the resultant force. Second will be come with the F equal to ma. Okay, so the F equal to resultant force, we get already 40. And be careful here, because of the whole system, we must addition both masses of the block. Where is the 10 kg and 5 kg here? Okay, will be equal to 15. Okay, so we substitute to the equation F equal to ma. I put capital N showing that is the total masses, okay, in this system. So we get our value is equal to 2.667 meter per second square. Okay, and then the C will be the tension of the road. Okay, so the tension of the road is at the middle of the whole system. So that means we cannot use the overall system to get the value of T. So that means we need to separate, okay, or we're using the partial system here. So you can select actually one of the partial system here where there is a 5 kg block system, or you can choose for the 10 kg block system here. Okay, so here we discuss the first system with the block 10 kg here. So I get the, firstly we get the free body diagram will be almost like this. And you can see the A moving at the right direction. So that means the T will be greater than G. Okay, so first we can get the resultant force. Okay, T minus G will be equal to MA. Okay, okay, so the G given 10 will be here. And because of we using the 10 kg block, okay, so we just substitute M equal to 10. No more, not 15 now, because we using partial system here. Okay, and the M is 10, and the A will be using the A we get from the question B. Okay, where the value is 2.667. So we get the final value here will be 36.67. So again, advise you to get 2 decimal places for your answer together with correct unit. Okay, so let's say you do want to choose the 10 kg block, you can choose also 5 kg block here. Okay, so again, you can draw the free body diagram. Okay, but if let's say you're already very clear and the question not request to do so, so you can just ignore and straight away imagine, okay, at the figure here. Okay, so you can see the air is actually move downward, so that means the weight will be greater than tension here. Okay, so here will be the resultant force together with MA. Okay, okay, so we rearrange the formula, we get this, and we substitute all the value given. So the M here will be 5 because we're using, okay, so here, sorry, here is a 5 kg. Because we're using 5 kg block, so the M here will be 5. G given by question is 10, and A we get from B. You will get the same value if using 5 kg compared to 10 kg block system. Okay. Okay, so we go to our last cases here. Okay, so 2 blocks are suspended on a smooth pulley by a light string. So the light string here, that means we negligible the value of the mass for the string. So we ignore the value for mass of the string here. Okay, so both blocks are released to move freely. Okay, so for this, you have to imagine the free body diagram here, where will be moved downward, where will be moved upward. So we very sure that at here you can see the capital M block will be moved downward. So that means the value M, capital M here will be greater than small letter m here. So for example, maybe the M block will be have 10 kg, and the small letter m must be smaller than 10, maybe 5 kg. Okay, so this is the imagination you need to imagine when you do this type of question. So again, the first equation you can get from whole system. So as I mentioned just now, for the whole system, we just need to observe the end-to-end forces. Okay, so here will be mg, small letter m with the mg capital M. Okay, so this is the first equation you can get. You will get 3 equations by using this system also. Okay, so first imagine, as mentioned, the crater mass will be moved downward and the lower mass of the block will be moved upward. Okay, so here I mentioned just now already, the M capital system will be moved downward because the mass is greater. Okay, and then you have to solve the equation. Okay, form and solve the equation. So what is the form of equation you can form? They will be resultant force, and the second you apply the second Newton law. Okay, I already mentioned the first resultant force. Okay, so that means that the capital mg will be minus small letter mg. Okay, that means the weight of the capital M minus the weight of the small letter m here. So you will get the resultant force here for whole system. Okay, and the second, applying the formula. So you will get N equal to MA. So the N here is the total masses for 2 blocks here. Okay, so you'll get these 2 equation. Okay, and then you can get the second equation at the partial system here. So here you can separate to 2 lah. Okay, so again, draw the free body diagram. Okay, this one just now I already mentioned. Okay, the main difference here is at step 2. So you can separate to 2 system, partial system. Okay, so the first will be the small letter m here. Okay, you get second equation, and you get another third equation by using another partial system here, which is showing by the system block with capital M here. Okay, so you have to draw the body diagram. Okay, so for the equation 2, by using the system block with small letter m, you can see the air is moving upward. So that means the T is greater than weight. Okay, I mentioned just now, you need to get resultant force. Second, okay, resultant force here will be T minus mg lah. Second will be F equal to ma. Okay, so m will be for the small letter m. Okay, so T minus mg will be, you get from the resultant force at the first assumption here lah. Okay, so that means you will be apply the same thing at your system block M here. Okay, when the M move downward, so the mg is greater than T. So you will get this equation. Okay, so how we apply in the question? Okay, so here the question A is also asking you the resultant force acting on the system. So that means it's whole system. So for whole system, you just need to observe end-to-end forces only. So here and here only. Okay, so mg for the 10 kg block, okay, you get 100. And the mg for the second block, which is 5 kg, you get 50. So 100 minus 50, you get 50 Newton. Okay, and B, question asking you to find out the value of A. Okay, so again, we're using F equal to ma, but the A here is the whole system. So that means we need to add both of the masses in the equation. So F you get from the A, and the total masses you get 15. So 50 divide 15, you get 3.333 meter per second square. Okay. Okay, so for the last tension of the rope, okay, so tension is at the middle of the system. So that means you need to use the partial system. So it's separate to two smaller systems. So you can choose 10 kg block system, or you can using the 5 kg block. Okay, this depends on what you are try to choose lah. Okay, so here I just show the 5 kg block. So here you can see for 5 kg block, so the air will be moved upward. Okay, because the mass of the 5 kg is less than the 10 kg. So for sure, will be moved up and moved down for the 10 kg. This is a simple imagination and the logical thinking you need to know lah. Okay. Okay, so the first get the resultant force. Okay, so T will be greater than W because of the motion is moved up. Okay, and then we're using F equal to MA. We substitute all the value given. So the phi will be 5 kg because we using the partial system at 5 kg block. Okay, and G equal to 10 question given already, and the A you get from the answer at B. So finally you get 66.67 Newton. Okay. Okay, so that's all for my discussion today. I hope that you can understand what I given to you today. Okay, so I pass back to moderator. Okay, Cikgu Izian.
Okey, terima kasih Mr. P. Okey, alhamdulillah dah selesai kelas kita pada petang ini. Okey, cikgu ucapkan tahniahlah kepada siapa yang setia bersama kelas pada petang ini dari awal hingga ke 3.17 lebih kurang 3.17 petang. Okey, jadi sebelum tamat sesi siaran langsung, mohon tutup ruangan chat dan klik butang subscribe dan juga aktifkan ikon lonceng supaya kamu tak terlepas sesi kelas yang seterusnya. Okey, jika anda suka dengan kelas hari ini, boleh klik like dan share kepada rakan-rakan media sosial kamu untuk kita sebarkan ilmu dan beroleh kebaikan di atas perkongsian tersebut. Okey, jadi cikgu berikan kod yang terakhir. Kod yang terakhir untuk hari ini adalah 16. Cikgu ulang ya, 16. Okey. Okey, jadi link sijil boleh didapatkan pada bahagian chat. Okey, link sijil tu akan tamat dalam tempoh setengah jam selepas live ini. Okey, jadi sebelum cikgu tamatkan kelas pada petang ini, cikgu nak jemput dipersilakan Cikgu Hasnita untuk memberikan sepatah dua kata.
Okey, terima kasih Cikgu Izian. Assalamualaikum dan selamat petang semua. Pertama sekali Cikgu nak ucapkan tahniah dan terima kasih kepada Mr. P atas perkongsian tadi. Cuma mungkin di last part itu soalan 5 dan 6 itu mungkin sedikit terlepas pandang. Nilai G itu kita guna 9.81. Itu tadi mungkin Mr. P guna 10 kan. Tadi mungkin untuk yang KSSM ni pelajar kena alert lah. Sekarang kita guna G 9.81 Newton per kg lah. G itu merujuk kepada kekuatan medan graviti bumi. Okey, untuk kira berat. Okey, jadi apapun keseluruhannya, okey, excellent, tahniah Mr. P dan senang diikuti. Bagi saya senang difahami dan pelajar-pelajar semua boleh cuba lagi di rumah dengan link yang dikongsikan oleh Mr. P. Anda boleh dapatkanlah kopi PDF kopi kepada slide yang dibincangkan tadi, sama ada di live chat ini ataupun di bahagian deskripsi video. Dan kepada yang beragama Islam, selamat berpuasa cikgu ucapkan, dan teruskanlah bersama dengan Pusat Tuition Academy YouTuber. InsyaAllah minggu depan cikgu akan sambung lagi untuk bab yang seterusnya 1.2, iaitu leraian daya, Resolution of Forces. Jadi jangan lupa janji temu kita untuk kelas tingkatan 4 untuk bulan Ramadan ini akan bersiaran pada hari Jumaat 3.30 petang. Minggu depan akan diteruskan dengan Cikgu Faizah dengan tajuk yang kedua 1.2, iaitu 1.2 graf. Okey, apa tadi? Kan betul kan? Okey, graf lah, graf gerakan lurus. Okey, linear graph. Lupa dah tajuk yang linear graph. Okey, dan cikgu akan teruskan dengan 1.2 untuk tingkatan 5 setiap Ahad pukul 2 petang. Okey, kembali kepada Cikgu Izian.
Okey, terima kasih Cikgu Hasnita. Okey, Cikgu nak ucapkan juga terima kasih kepada semua penyokong Akademi YouTuber. Doakan kami terus kuat dan bersemangat untuk membantu dalam membangunkan pendidikan Malaysia. Okey, sekian itu saja. Assalamualaikum. Bye.
Okay, sebelum tu cikgu kongsikan dulu lupa nak letak tadi username presenter. Okey, ada
okey.
dekat link chat lah.
Oh.
Okey.
Okey, dah ada
Ya.
link rekod kredit, link isi jail dan juga username presenter.
Okey, jadi jumpa lagi dalam kelas akan datang. Bye-bye.
Okay,
Terima
bye.
kasih semua.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.